Hello, I'm Mike Heroux, and I'm here talking with Addi Malviya-Thakur and Ryan Adamson from Oak Ridge National Laboratory. I'm part of the organizing committee for the 2021 Collegeville Workshop on Scientific Software. This year's theme is on software teams. Addi and Ryan have provided a white paper for the workshop that you can find on the Collegeville Workshop website. And we're going to talk through some of the highlights of that paper and other topics as they might emerge. So let's just get started. So as I read your paper, your focus is on the software lifecycle, including the possibility that a product would never make its way out of research into the production setting. And so you identified a kind of research to production life cycle and exposed some of the interplay between those phases and the kind of key skills that are needed to make for a successful operationalized piece of software. Can you describe a little bit more about the approach that you've written here?
Absolutely. So Addi and I come from two different sides of this life cycle. She is much more of a developer than I am, and I'm much more of an operations person than she is. And so coming together in this new, I guess, DevSecOps space where we're trying to work more together as a team, right? Integrated team.
Right. And that stands for Development, Security, and Operations. Is that correct?
That's right. That's right.
Okay, thank you.
And sort of sharing the tools between each of those domains, right? We sort of were talking about some of the projects that we had been on and how to prevent, last minute oopses or missing some requirements, when there are customer expectations of things being delivered. And so we just started talking about that problem. And it seems that there is a trade-off, and that's what we propose in the white paper, between at the very beginning, spending a lot of time doing requirements gathering and analysis, if you know where your product will be deployed, versus the fact that not all of these research prototypes end up being viable. The fundamental part of research is trying new things, and failure can be a part of that. And you can write about failure and say this didn't work because of these reasons. And so, operationalization too early can be wasted effort. And so then we take that and we look at that effort through the lens of toil, which is it's an operations concept that Google has written about quite a bit with their site reliability engineering teams, where you want to automate and sort of work that's not useful, you want to tune down. And so we use those tools to look at that spectrum of when do you engage the systems engineers and when do you not?
Yeah, very good. Thank you. Now, I also understand that each of you have had some life experience that informs, what you wrote in a general sense. Can you maybe describe a little bit, maybe starting with Addi, an experience that feeds into what you've learned?
Absolutely. So one of the very interesting things about this year's theme on software teams was that as much as this is a process problem, it's also a teams problem. So, for example, one of the projects we worked on earlier this year, we completely had the element of empathize with other teams missing, that the one that we mentioned here. So we essentially say like, hey, we have this development team, we wrote the research prototype, it got accepted, we're demoing it now. Now, all of a sudden, the distance between demoing it and now we want it in operation is just so fast that we completely forget to empathize with the other team that may be more on the operations side, and they have constraints about security, scalability, all kinds of different things before they can let this research prototype and demo come into operation. However, at that point, it's very difficult to manage the requirements from the research sponsor side, because they just approved the demo, they really like it, now they want it. But at that point, when we start exploring these relationships and these requirements and how do we work through this, it's almost too late in the game. So that was definitely one of the experiences this year. that played into a lot of my conversations with Ryan, and we were saying like, yeah, we need to come up with a framework that doesn't put us in either of the extreme ends. We need to be somewhere in the middle where we were prepared, but not over prepared, if you will. So
yeah, very good.
That happened this year. We had no idea of the deployment requirements up front, which is the nature of almost all research projects, because when we start and we're developing the algorithms, there is no operational requirement to begin with, because there is just no expectations. But as the project moves on and the demos are successful, that requirement gathering process and cycle becomes really small. So I'm pretty sure that there must have been some things that we did in the end that we could have done up front, which would have made this a lot smoother. So definitely such a framework and following it would have helped.
Yeah, very good. Yeah, very nice. Ryan, how about you? I'm sure you have examples coming from the operations side, right?
I definitely do. And I just also want to start off by saying, even though I am on the operations side, I really hate saying no.
Yeah, sure.
Because these are really cool tools that are being developed, really cool, frameworks that are being developed. And so we really do try to bring them into production as in the right way. One of my early experiences in my career, really right after I got into HPC, was with updating an application that kept track of a lot of our scientific allocations, and we used it for reporting and understanding access to systems and things like that. And it was a research project. I think it was a master's thesis project, and so and it was the only tool that fit the needs right at the time.
Yeah.
But as we grew, it became outdated. We needed more features, but it was very opaque, right? We didn't apply a lot of the best practices for agile software development. And I remember that the deployment of that tool, upgrading right to a new version that would be easier. I think we had like a week-long downtime where we couldn't really do the things that we need to do to operate the center, and so that left a really big impression on me in terms of making sure that we do have CI/CD pipelines set up and unit tests written, and sort of doing that on the front end, if we know that the needs are going to grow in that operational way. And we were very successful in wrangling that application to fit those needs, but it did take time and effort and work, and it took coming together in a DevSecOps way. So
yeah, very good, very good. So Addi, from your perspective as being more on the development side of things, well, maybe let's start with Ryan first. Being on the operational side of things, what are a handful of things that you would love to tell a research software developer to pay attention to or do, from the beginning or near the beginning to make your life easier and their life easier?
Absolutely. So first off, I think empathy and empathizing with other teams, as Addi had mentioned, is so important. If you respect the work that others are doing, you tend to speak on each other's level, right? Yeah. And I would say that the way that I think about that, and there's a diagram in the white paper, it's figure 1, that when you take on a responsibility, let's say you're a developer or you're an operations person, you're signing up to deliver something, and you want to do a good job. You want that to be a quality capability, right? But for you to really feel comfortable doing it and feel like you own it, in the way that I like to own my applications or services, one has to have authority over how to deliver that, and they have to have I call it the capability to deliver it. This is the knowledge or the time, the funding. Yep. And all three of those have to line up, or folks don't feel very good about the work that they're doing. And so through the DevSecOps lens, the security team has security responsibility for the app. The operations team has the operations responsibility for the application, and the scientific development team has development responsibility. And so you have to split that authority up and still communicate in order for everyone to feel good about that they're in control of their own destiny. And so I think that's the most important thing that I would mention here.
Yeah, that's excellent. Okay, Addi, now to you. As a research software developer or leader of a team, what would you want the other side of the pipeline to know or to do in preparation for what you're developing?
Definitely. So I think that in some of our section where we talk about reducing the toil, I think Ryan and I went back and forth and we said, well, this length, we have to stop at that because of, our requirements. But if we get an opportunity to expand, we talked about a lot of approaches that would be so helpful. So for example, we would want to connect with the ops teams earlier to figure out, now we have so many container-based technologies. So starting your development with those technologies automatically takes some of those requirements away. So connecting up front on figuring out like, hey, what are the possible solutions that we use to develop may be easier to put into operation. And then instead of doing a better bare metal development, we should use some of those approaches. And then we can have things like, hey, are there any specific cybersecurity requirements that are already established that can be shared up front with us? I think we also wrote that sometimes people are not really open because, again, it's that authority model because they feel like we're on the operation side, we'll deal with that, don't worry about it. And I think Ryan and I discussed that it would be great to know what we can't do upfront and not when we already have a prototype ready and we're told like, well, you absolutely cannot use this technology or that will never be approved by cybersecurity. So I feel like just engaging up front, even though we will not be working together or have no idea if this will be an operational software, but also just extending our framework, we do want to identify some of those common things by doing a few case studies on both of our projects and say like, hey, let's recommend everybody do these 4 or 5 things. And, like we would have covered up to 80% cases in that. So I definitely see a lot of value in just kind of connecting together and finding how we can approach and meet in the middle somehow. That'd be beneficial.
Yeah, very good. I just a couple more questions. One is, this is my experience that I think it's maybe the operations folks know this, but by and large in the research software community and even among our sponsors, there seems to not be enough awareness of how much effort and cost and time it takes to operationalize a piece of software. And so I'm just curious if that's also your experience, and if you have ways to try to convey, build that awareness within our community, because I think that's needed, right? We need to have a mental model that says it really takes a lot to operationalize a piece of software.
That's a great observation, and it's not only operationalizing it where you might put logging capabilities on, make sure that authentication works correctly and make sure that disaster recovery or parallelism and things like that, right? But also
you had some nice comments about databases, for example, right? Too.
Exactly. And all software over time, the dependencies under software is not static, right? I mean, it lives on, and so I mean. It's akin. I'm sure in the software development community, you all understand or have a feel for the amount of effort it takes to maintain a piece of software. It's probably very similar to to that, where you can think, oh, it's just sure I'll update it when I need to, but no, you can have several people. That's all they do on a larger project. Is pull in and new merge requests, fix bugs because library dependencies have changed and. It's like staying on top of the trash compactor in Star Wars. You just have to like stay on top of it, right? So that
right.
That's but I agree. I think if there's a way to quantify it or like as Addi said, even look further into the different successes, and I don't like calling them failures because we learn from the things that don't go as well as we would have liked, right? But to improve upon this white paper and dig into a lot of these case studies that I'm sure everybody has great examples to see on average how many people does it take for these types of projects, just to get a feel for the amount of effort required.
Yeah, very good. Thank you. Thanks. Any more comments from you, Addi, in this?
Sure. So I feel like from the research software engineering side, there's definitely some approaches that we need to follow to engage the sponsors to see the value in this, especially for doing it upfront. Some of the times, like you mentioned, upfront in the project, there is no plan to put anything in operation. So you might see some pushback about collecting a lot of requirements that lean that way. So one of the approaches that, I mean, we would love to expand on some things that do work, have been to really emphasize the scalability of the solution that we would obtain as a result of this, or just the reproducibility, because we'd be like, hey, you can take this research algorithm from here and you'll be able to run it there and for more users and exact same results. Or the scale of data where we are not prototyping that with, let's say, a few gigabytes, but you may be able to scale it up to all of the terabytes of data that you have at the source. Just framing the question of operational requirements that way has really helped us a lot, because then they are able to relate that back to the impact of the amount of science that can be done. And they are very, very keen to provide those versus us saying, hey, we need some operational requirements.
Yeah, very good, very good. Thank you. Great response. Last question. In your paper, you have a small section on manage the sponsor. And I'd love to, I think it's a very important point, and I'd love to hear you elaborate a bit on that, if you don't mind.
Sure. So I'll start, but I think Addi probably has much more experience managing the sponsor, since I just get my little operations funding bucket. Essentially, what we're trying to do here is lay out the facts. These are the fundamental truths about the way that scientific software ends up being operationalized, and we shouldn't be afraid of that. So what I'm really saying is, we should tell the sponsor that there is a trade-off between getting lots of operational requirements early but having wasted work, or delaying too long, and we need to plan for some amount of rework when we demonstrate this in a prototype kind of way, and having that in the project schedule, or the funding for that up front 2 years before you're even demoing the prototype, I think really helps to set the stage for a successful transition to operations.
Yeah, thank you very much. Addi, what about you? More comment?
Yeah, from my perspective, I think it depends project to project. Sometimes we also run into these kind of problems that the moment we say the word operation, we're told that the color of money, we cannot really use this bucket for operations. So we have to really make sure that we understand where the sponsors are coming from. What is the question? What does the PWS say? How do we take that and make sure that we can bring all of these aspects in a way that works for that particular project? Maybe that's what you would say, like managing it in some way, because from the research software engineering side, we can really see on both ends. We can see like what we need to deliver up, but we also want to work with the other teams that are going to really make it happen so that it's reproducible and scalable. So we have to make sure that we include that with the other items as we deem fit. There may not always be a bucket for operations, and we just have to understand that.
Yeah, very good, very good. Well, I thank you both for speaking with me today. It's been a pleasure to talk through some of the high points of your white paper. So we'll wrap it up, and hopefully people will have a chance to view this video, both prior to the workshop coming up July 20th through the 22nd of 2021, or afterwards. We'll be posting this video on the Collegeville YouTube channel. So thank you, Ryan and Addi, and talk to you later. Bye.
Awesome. Thank you, Mike.